Hi viewers, welcome to JSM. In this video, I am going to discuss previous NEET questions related to the classification of elements from that ionization energy and different radius and stability of oxidation states and paramagnetic behavior. So let us discuss the first question. The correct order of the decreasing ionic radii among following isoelectronic species. So which isoelectronic species they given? First see that. So they given calcium plus 2 and they given K plus and Cl minus as 2 minus. Okay. So these are the isoelectronics. Why they are isoelectronic species? Because they have same number of electrons. Here S, sulfur actually having 16. Here 2 minus means extra 2 electrons. 16 plus 2, 18 electrons. Cl 17. Here minus 1 means 1 extra, 18 electrons. Potassium 19 electrons. And here plus indicating loss of 1 electron. That's why 18 electrons here. Calcium actually 20 electrons. Here plus 2. Deficiency of 2 electrons. Loss of 2 electrons. That's why 18 electrons. In all species, 18 electrons only present. That's why they are called as isoelectronic species. So according to the ionic radius, we can say that as the positive charge increases, size decreases. As the negative charge increases, size increases. When you observe here, for example, here atom A is present, here A plus is there, here A minus is present. Compared to the neutral atom, anion size is greater. Compared to the neutral, cation size is less. Okay, so based on this relation, we can say here anions with more charge have more radius and cations with more charge have less radius. So based on that, we can say here sulfur with more negative charge. Sulfur with more negative charge, that's why its ionic radius is more than the Cl minus, because here Cl minus only 1 minus is there, right? Compared to the anion, cation size is less, that's why K plus is lesser in size compared to the Cl minus. Then here in the potassium 1 positive charge is there, in the calcium 2 positive charges are there, that's why as the positive charge increases, size of the ion module happens decreases. That's why this is the correct decreasing order of ionic radius. That's why which option is correct here? This C, option C, S2 minus, Cl minus, K plus and calcium 2 plus is the correct. Then let us see the stability of plus 1 oxidation state increases in the sequence. Here atoms given, they are aluminium, gallium, indium, okay, and thallium. 4 atoms given, okay, from top to bottom. Okay, see here aluminium, gallium, indium, thallium belongs to the 13th group or third A group. Okay, when you go from top to bottom in a third group, third A group or 13th group, what will happens? Plus 1 oxidation state, okay, plus 1 oxidation state increases. Plus 1 oxidation state, what will happen? Increases due to inert pair effect. Inert pair effect. So that's why what we can say here, when you go from aluminium to thallium, stability of plus 1 oxidation state increases. That's why order will be, okay, thallium is greater than, then indium, thallium plus 1 is greater than indium plus 1, then gallium plus 1 and aluminium plus 1. From aluminium to thallium, okay, when you go from top to bottom in a group, lower oxidation state, plus 1 oxidation state, what will happen? Increases due to inert pair effect. That's why which option is correct here? Thallium, indium, gallium and aluminium. Option D is correct. Then let us see next one. Which of the following electron configurations of an atom has the lowest ionization energy? So here ionization energy means we know that the minimum amount of energy required to remove an electron from outermost shell of neutral isolated gaseous atom is known as ionization energy. Okay, so let us see here The configuration is given 1s2, 2s2, 2p3. 1s2, 2s2, 2p3 means atom is nitrogen. Then 1s2, 2s2, 2p6 and 3s1 means here it is sodium. Then 1s2, 2s2, 2p6, 10 electrons are there. That's why it is neon. Then 1s2, 2s2, 2p5, here totally 9 electrons are there. That's why you can say it is a fluorine. Okay. Here sodium belongs to the first A group. Sodium belongs to the first A group or first group. Then nitrogen belongs to fifth A. Fluorine belongs to 7th A and neon belongs to 18th group, means 0 group. Okay, noble gas. When you see here, sodium is a metal. Sodium is a metal. Compared to the non-metals, metal size is more. When the metal size is more, the minimum amount of energy required to remove electron from the outermost shell. That's why which one having lowest ionization energy here? Sodium shows the more ionization energy. Okay, sodium with the lowest ionization energy, because it is a metal. Its atomic size is more. Due to atomic size is more, nuclear attractions on outer electron is less. That's why less amount of energy required to remove electron from the outermost shell. That's why which option is correct here? B option is correct. For the sodium, lowest ionization energy is there. So next one, which of the following oxide is expected to exhibit paramagnetic behavior? So we know, simply we can say, to show the paramagnetic nature, okay, there should be odd number of valence electrons. The species with odd number of valence electrons, we can say simply they are paramagnetic. If the species with odd number of valence electrons, they are diamagnetic nature. When you see the valence electrons, carbon valence electrons 4, here 2 oxygens are there, each oxygen with 6 valence electrons, 4 plus 6 plus 6, totally 16 electrons. Okay, even number of electrons. SiO2 is there, silicon 4 electrons, oxygen 6 plus 6, the totally 16 electrons are there, even number. So here even number. Then S4 2, sulfur 6, oxygen 6 and one more oxygen 6, totally 18 electrons. This is also said to be even. When come to the chlorine 7 valence electrons, oxygen 6 and one more oxygen 6, 12, 7, how many? 19 electrons are there totally. How many electrons here? 19 electrons are present. So 19 electron is a odd number. That's why what we can say here, the even number of electrons containing species, even number of valence electron containing species is said to be diamagnetic species. Then odd number of electrons containing species is said to be paramagnetic species. That's why which option is correct here? D. ClO2 have odd number of electrons, that's why it is said to be paramagnetic behavior. It contain paramagnetic behavior. Let us see next question. Question is, the first ionization potential of beryllium and boron respectively are. Okay, here different options given. From the given options you have to find out the first ionization potentials of beryllium and boron. Okay, so what you can think here, so beryllium and boron belongs to the second period. So we know that when you go from left to right in a period, size what will happen? Size decreases, ionization energy increases. That is the expected thing. Okay, that is the expected. Based on this we can write expected order is beryllium is less than boron. This we are expecting. Okay, that based on the, when you go from left to right in a period, size of atom decreases, then ionization increases. That is the expected order is beryllium is less than the boron. But actual order is which one? Beryllium is greater than boron. This is the actual order. So what is reason behind this? So why it will happens? Okay, let us see. So beryllium electronic configuration 1s2 2s2, boron electronic configuration 1s2 2s2 2p1. So here when you see this electronic configuration, this is completely filled electronic configuration. This is a completely filled electronic configuration. So when come to here, this is a incompletely filled electronic configuration. So when incompletely filled electronic configuration is present, that is very, very unstable. When completely filled configuration is present, that atom is very stable. That's why due to the presence of completely filled stable configuration, to remove electron from the beryllium, more amount of energy required. That's why we can say beryllium shows more ionization energy than the boron. That is the reason. What is the reason here? Because completely filled configuration present in the beryllium, then it gets stability. That's why which option is correct? Beryllium should be greater than the boron. Okay, this is the beryllium, this is for boron, this is for beryllium, this is for boron, this is for beryllium, this is for boron, this is for beryllium, and this is for boron. Okay, here similar ionization energies are there, that's why this is the wrong option. Here also similar ionization, that's why this is the wrong answer. According to the actual order, beryllium should be greater, that's why which option will come? 9.32 for beryllium, 8.29 for the boron. That's why option D is correct. When come to the next question, among the following oxides, the one which is most basic. So remember, so very, very simple, this point is the oxide which is formed by the metal. Okay, the oxides of metal is most basic or more basic. Okay, oxide of metal is more basic. See here, zinc is a metal, magnesium is a metal, aluminum also. Okay, but here N2O5, nitrogen is a non-metal, that's why we can say it will not comes under the basic oxide. It is definitely acidic oxide. So definitely we can say it is acidic oxide. But when come to the zinc and aluminum, so due to their metalloid nature, they are amphoteric oxides. Zinc oxide and aluminum oxides are amphoteric oxides. Then when come to the magnesium oxide, so magnesium is a pure metal. Okay, and it belongs to secondary group. Its metallic nature is more. That's why we can say magnesium oxide is a most basic. Magnesium oxide is a most basic. That's why which option is correct? Magnesium oxide, B. Option B is correct. Okay.